Hello everyone, my name is Anis and today we will discuss about motion in a straight line. So here it is motion now. So when you will say that particle is in a motion, if that particle it changes its position with respect to its surrounding with time, then we can say that that particle is in motion. Now motion in a straight line. Here it is straight line. So straight line means here it is in one dimension. That body it may be at rest or moving in a straight line. Then we can say that the body it is at rest or it is moving in a straight line. So it is one dimension. So before we learn about motion in a straight line, let us discuss about mechanics. So what do you mean by mechanics? Mechanics, it is a branch of physics. It is a branch of physics which deals with the study, of rest or motion of a material object. Okay, so mechanics it is a branch of physics which deals with the study of rest or motion of a material object. So now here in mechanics there are three branches. Here. So those three branches are first one statics mechanics. Second one kinematics mechanics. Third one dynamics mechanics. Okay, so here there are three types of mechanics. Now first one is static mechanics, second one is kinematic mechanics, third one is dynamics mechanics. So now we'll discuss about these three mechanics now one by one. So first one here now. First one static mechanics. So here now, what do you mean by static mechanics? So static mechanics, it is a branch of mechanics which deals with the study of particle at rest. Okay, so here it is a branch of mechanics which deals with the study of particle at rest. So here static means it is nothing but it is rest here. So here now, as its name implies, it is a branch of physics which deals with the study of particle at rest. So now second one is kinematics here. Now second one is kinematics mechanics. Kinematic mechanics. So what do you mean by kinematic here now again? Kinematic means it is also a branch of mechanics which deals with the study of which deals with the study of study which deals with the study of which deals with the study of particle in motion without going into its causes. Here in kinematics, we study about the particle in motion without going into its causes. Okay, so why it is going, we will not learn here in this mechanics. So next, third one is dynamic mechanics or dynamic. Third one is dynamic mechanics. Third one is dynamic mechanics. So here again, dynamics mechanics, it is also a branch of mechanics. Here we study not only particle is in motion, but also its causes. Here in dynamics mechanics, it is also a branch of mechanics. Here we study not only about particle in motion but also its causes, why it is in motion. Okay, so now this is about the mechanics. Here mechanics, it is a branch of physics which deals with the study of rest or motion of material objects. So here there are three branches: static mechanics, kinematic mechanics and dynamics mechanics. So what do you mean by static mechanics here? Static mechanics means it is also a branch of mechanics which deals with the study of particle at rest. So second one, kinematic mechanics, it is a branch of mechanics which deals with the study of particle in motion without going into its causes here. And in third one, dynamics mechanics, here we study not only about particle in motion but also its causes. Okay, so these are the three types of mechanics. Next, so this was about the mechanics. Next, we'll see motion. As I have said, motion. So what do you mean by motion now? Okay, so motion, a particle is said to be in motion. A particle is said to be in motion. A particle is said to be in motion if it changes its position from one point to another point. Okay, a particle is said to be in motion if it changes its position from one point to another point. Okay, so here I have said a particle is said to be in motion if it changes its position from one point to another point. So for example, let us consider I am sitting in a car. Now I will go to some shop from my home in the car. So the initial point, okay, it was my house, and the final point it is the shop. Okay, so it has changed its position with respect to its surrounding and with time. Yes, so then you can say that the particle is in motion. Okay, or another example, you are sitting in the train now. Yes, so the train is moving. So the train is moving now. So it will change its position with one station to another station. Yes. So now then we can say that the particle is in the train is in motion here. Yes. So this was about the motion. So next we will see about rest and motion. Next we will see about rest and motion, related rest and motion. So rest and motion both are interrelated here. Both are interrelated. So for example, let us consider you are in the train, you are sitting in the train now. Okay, and the train is moving now. It is in motion. So here you are sitting, you are at rest with respect to the train. You are at rest with respect to the train. But the train, it is in motion with respect to the surrounding. Yes. So this is the relation between rest and motion. This is the relation between rest and motion. Next we will see point object. Point object. So point object, when you will say that the object is a point. So for example, now you are standing on the earth surface. Okay, so now in the sky there are many stars here. Those stars are very huge, but they look like a point to you. Yes, so why is that? Because here the diameter of that stars, the diameter of those stars is less compared to the distance from the surface of the earth or from you to the star. So those object or star look like a point for you. Okay, so this is about the point object. Next we'll see about one dimension. Dimensions. So first we'll see one dimension. One dimension. So one dimension here, one dimension means it is in one dimension. A body, if the body is in rest, okay, if the body is in rest or it is moving in a straight line. So for example, take a train here now. It is a 2-track, take a train. So the train, it will move straight. It will be moving straight. Yes. So the train is in a one dimension, we can say. It is moving in a one dimension, we can say. Okay. So next, two dimension. Two dimension. So two dimension. For one dimension, here it is only x direction, or you can take only y direction, or you can take only z direction. But for two dimension, here it is x, it is y. Okay, so here there are two dimensions now, x direction and y direction. So for this example is an ant crawling on the globe, we can take an ant crawling on the globe, we can take. So this is an example for the two dimension. Again another example for one dimension. Okay, the ball is moving in the, you are throwing the ball in the upward direction. If you throw the ball in the upward direction, it is moving in the single direction. Yes. Yes. So this is the one dimension example, and the example for two dimension is an ant crawling on the globe. Okay. Next for three dimension. Three dimension. Yes. So three dimension here. Wait. So here in three dimension, the directions will be three directions. How many directions? There will be three directions. So here this is the z direction. Okay. So this is x, this is y, this is z direction here. So the example for three dimension is a kite flying in the windy wind. Okay. So now a kite is flying in the sky, in the windy sky you can say. Another example is an aeroplane flying in the sky. Yes, an aeroplane flying in the sky. These are the example for the three dimensions. Okay. So next we will see about displacement and distance. So first we will see displacement. First we will see displacement. So what do you mean by displacement here? Displacement means it is the shortest distance between initial and final point. Initial and final point. So for example here now, let us consider 3 points. Okay. So now for example from here to here, this is point A, this is point B now. Okay. So now a particle is moving from point A to point B here. So from point B, again this particle is moving in this direction. Let us say point C now. Okay, so from point A to point B, so from point A to point C. Okay, from point A to point C, the shortest distance will be, okay, this is a triangle now. Yes, so the shortest will be A to C. AC will be the shortest distance here. Yes, so this shortest distance, it is a displacement. It is known as displacement here. Okay, so next we will see about distance now. Next we will see about distance. Distance. So what do you mean by distance here again? Distance, it is the path length. It is the path length covered by the particle from initial point to final point. Initial point to final point. Okay, so here now again, see here now again, distance, it is a path length covered by the particle from initial point to final point. So now the particle, it is moving from point A to point B. Then it will go to point C here. Yes. So we will not see the shortest, this one here. We will see that distance covered the particle. First it will go to point B. From point B it will go to point C. So for example, now I am moving from Bangalore to Hyderabad. Okay, I will go from Bangalore to Hyderabad. Again from Hyderabad I will go to Mumbai. Yes. So this is the Bangalore, this is the Hyderabad. Then I am going to the Mumbai here. Yes. So here I will distance the total path covered here from point A to point B, from again point B to point C. Total distance I will get there. So this is known as distance here. But displacement means I am choosing the shortest distance here from point A to point C. It is. Okay. So here the SI unit for displacement and SI unit for displacement and distance is meter. SI unit is meter. And dimensional formula is m raised to 0, L raised to 1, T raised to 0. Here only length will be here. Meter means it is length here. Okay. So this is about the distance and displacement. Next we'll see about speed. Next we'll see about speed here. So speed. So what do you mean by speed here? What do you mean by speed? So speed, it is a rate of change of position. It is a rate of change of position. It is rate of change of position with time. Rate of change of position with time here. Rate of change of position with time. Yes. So again, next we will see uniform speed. Next we will see uniform speed. Uniform speed here. Uniform speed. So what do you mean by uniform speed? Okay. So uniform speed, we can say that the particle is moving with a uniform speed if it covers equal, if it covers equal distance in equal distance in equal interval of time, in equal interval of time. If it covers equal distance in equal interval of time, okay, then we can say that the particle is moving with uniform speed. Okay, so this is about the uniform speed. Next we will see variable speed. Next we will see variable speed. Sorry. Variable speed. So again, what do you mean by variable speed? We can say that the particle is moving with variable speed if it covers equal distance in unequal interval of time, or 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 equal distance in unequal interval of time, or unequal distance in equal interval of time. So when you say that the particle is moving with variable speed here now, if it covers equal distance in unequal interval of time, or if unequal distance in equal interval of time, then we can say that the particle is moving with variable speed. Okay. Next we will see average velocity. Average speed, not velocity, speed. So average speed means it is a ratio. It is a ratio of average speed means it is a ratio of total distance it is a width. We'll write like this, defined as the ratio of total distance to total time taken. Okay, so here average speed means it is the ratio of total distance divided by total time taken. So this is the average speed. Next we will see instantaneous speed now. Next we will see instantaneous speed. So what do you mean by instantaneous speed again? So instantaneous speed. So instantaneous speed means it is a speed at that instant of time in a time interval. Okay, it is the speed at that instant of time in a time interval. Okay, so the speed at that instant of time in a time interval is known as instantaneous speed. Okay, so here speed, it is a scalar quantity. Speed is a scalar quantity. Speed is a scalar. Speed is a scalar quantity. Next we will see next we will see here now velocity. Next we will see velocity. So again now velocity. What do you mean by velocity now? Velocity, it is also rate of change of position It is also rate of change of position with the time. Rate of change of position with time. With time. So here velocity, it is a vector quantity. It is a vector quantity. Velocity is a vector quantity. Here it is a, here the speed is scalar quantity. Speed is scalar quantity. Okay. So now we will say again here velocity. Okay. So velocity, it is a rate of change of position with time. Next we will see uniform velocity. Uniform velocity. So what do you mean by uniform velocity? Uniform velocity, we can say that a particle is moving with a uniform velocity if it covers equal displacement in equal interval of time. Equal interval of time. Then we can say that the particle is moving with a uniform velocity. Okay. So next we will see variable velocity. Variable velocity. Okay. So variable velocity, when you will say that a particle is moving with a variable velocity, here variable velocity, if a particle covers equal displacement in unequal interval of time or unequal displacement in equal interval of time. Okay. So variable velocity, when you will say that a particle is moving with a variable velocity if that particle covers unequal distance, unequal displacement, if that particle covers unequal displacement in equal interval of time or equal displacement in unequal interval of time. It is not equal, it is equal. Okay. So this is about the variable velocity. Here in uniform velocity, if that particle, if it covers, means it is a particle covers equal displacement in equal interval of time. Next, here we will see average velocity. Average velocity. So average velocity, it is a ratio of total displacement to the total time taken, or we can say particular time taken. So here we can write the mathematical equation also. Average velocity, here I will write total displacement divided by total time taken. Yes, so this is about the average velocity. Next we'll see instantaneous velocity. Instantaneous velocity. Instantaneous. Okay, so again we know that instantaneous, what do you mean by instantaneous? Speed. Here instantaneous speed means the speed at the instant of time in a time interval. Here it is the velocity. It is the velocity at that instant of time in a particular time interval. So here it is the velocity at that instant of time in a particular time interval. Means, for example, now the train is moving now. Okay, so the train, it will move from Bangalore station to Hyderabad. Yes, so in between there are some stations. Yes, so let us consider some particular time interval in that. So at that time interval, what will be its velocity? That velocity, it is known as instantaneous velocity. That velocity is known as instantaneous velocity. Okay, so here now see here in speed and velocity. Here in speed it is distance, and in velocity it is displacement here. So definitions are both are same little bit, but the word used is in speed is distance and in velocity is displacement. Okay, so this is about the speed and velocity. Okay, so now this is it for today's class, everyone. Thank you.